Dear viewers and dear parents, we are now moving on to the first chapter in CBSE called Unit and Measurement. Now, in the previous chapter itself, we already demonstrated what will be the learning continuum. Here, now in the content, we want to apply the learning continuum so that children can able to remember the content very well like a story. This is the methodology that is being really used to construct science in the minds of the youngs. So let us get into the portion straight away. Dear students, every lesson in 11th standard first volume branch called mechanics are interconnected. Let us see the relations, how it is really being connected and how well we can be able to remember the particular content. Now let us get into the portions. So now the very important portion here is the unit and measurement. This unit and measurement is a topic that is really concerned with the nature of the subject called physics. You already know there is a war between the nature and the mankind. Mankind explores nature and identify and discover the knowledge about nature. They call it as a science. Next, the branch in science is called physics, which really studies about the matter. In order to study the matter and the energy relation, physics uses one important thing called measurement. So the first lesson is really being related to the second lesson. Whenever we call the physical quantity, in order to study the properties of the physical quantity, in order to study what is happening in the physical quantity, we have to study the physical quantity properties, quantities, which can be measured and by which various physical happenings can be explained and expressed in the form of law is called a physical quantity. If a physical quantity is there in the universe, its property should be measured. For example, length, mass, time, force, etc. are the properties of the physical quantity. Some of the quantity we cannot able to measure. Let me suppose. For example, what is happening in our life? Happiness, sorrow, whatever may be the things, these are all the feelings. These feelings cannot be measured means which may not fall under physics. Physics deals with the matter. Matter deals with physical quantity. Physical quantity properties can be measured. If the quantities are measured precisely, we can able to infer and define a law governing the physical quantity property. Very nice. We'll get into the next thing. Physics describes the law of nature. The description is quantitative and involves measurement and comparison of physical quantity. To measure a physical quantity, we need some standard unit of that quantity. Here, let me show you an example. We want to say an elephant is heavier than goat. But exactly how many times? The question can be easily answered if we have chosen a standard mass, calling it a unit mass. We are going to compare the elephant with the goat. In order to compare these two quantities, we are going to have a standard mass called a unit mass. If the elephant is 200 times the unit mass and the goat is 20 times the unit mass, we know that elephant is 10 times heavier than the goat. So matter, properties of matter. In order to measure the properties of matter, we need a scale. In order to construct a scale, we need a standard unit which is universally acceptable. The standard unit through which the scale is constructed. With the scale, the quantities are really measured. Here, 200 times standard unit is the mass of the elephant. 20 times the standard unit is the mass of the goat. So we can compare and then say it is 10 times bigger. It is 10 times bigger. So standard unit is one by which a scale is constructed to measure the properties of matter. Okay. So physics is the study of the natural phenomena based on measurement. A physical quantity is one which is got the precise definition and which is used for explaining the natural phenomena. Physical quantities should be amenable for measurement either by direct or by indirect. Matter, physics is the study of matter, actually non-living things. A physical quantity, we are really going to measure the property of the physical quantity by precise unit and scale by which we are going to define the property exactly so that we can go to a logical conclusion to derive a law. So physics means a study of matter. Physics means we are really studying the properties of matter. In order to study the properties of matter, we need a scale. In order to construct a scale, we need a standard unit. The unit and the multiples and submultiples of the unit can able to give a scale. With the scale, we can measure the properties precisely of the matter. Next, scale requires unit to construct. Measurement is necessary to determine the magnitude of the physical quantity. To compare the two similar physical quantities and to improve and to prove physical laws and equation, we need to compare. Measurement of any physical quantity involves comparison with certain basic, arbitrarily chosen, internationally accepted reference standard called unit. Physics tried to measure the properties of matter. Properties of matters are measured uniquely by a scale. The scale is constructed by a unit. The unit is basic, arbitrarily chosen, internationally accepted, and a standard called unit. Now, unit is a standard quantity of the same kind with which a physical quantity can be compared for measuring it. For example, if length is to be measured, we compared it to a standard meter scale. But meter scale is constructed by a unit called 1 millimeter. 1 millimeter is the unit. With the unit, a meter scale, standard meter scale is really being constructed. With the help of the standard meter scale, the quantity called length is really measured in physics. So, in order to represent the quantities property, physical quantities are quantitatively expressed in terms of unit of that particular quantity. The measurement of the quantity is mentioned in two parts. The first part gives how many times the standard unit, and the second part gives the name of the unit. For example, if I am studying for 2 hours, hours is the standard unit, 2 is the numerical value, 2 hours is the quantity, 2 hours is the time by which I have really concentrate on the subject called physics. The numerical part 2 says that it is 2 times the unit of time, and the second part hour says the unit chosen for measuring the time. So unit plus numerical value gives the quantity value. Quantity value can be expressed as n into u, where u is called unit, n is called the numerical value of the unit. Numerical value of the unit. So, a physical quantity is represented completely by its magnitude and unit. 10 meter means meter is a unit, 10 is a numerical value. 1 kilogram means kilogram is a unit, 1 is a numerical value. Hence, a physical quantity Q can be represented by means of the product of magnitude and unit. N is called the magnitude and U is called the unit, Q is called the quantity. So Q is expressed as N into U. Now, N into U for a physical quantity is a constant. For example, I am measuring a length. The length is called a quantity's property. Here, the length is measured by a centimeter scale. Here, centimeter is a unit. So 10 centimeter can also be expressed as 100 millimeter. Now, the unit is millimeter, N is 100. Previously, 10 centimeter, centimeter is the unit and 10 is the numerical value. Now I am going to say it is 100 millimeter. Now unit is millimeter and the numerical value is 100. So whatever may be the things, the quantity property called length is not going to change, but the unit is going to change. Correspondingly, the numerical value is also going to change. So we can say N into U is constant. When unit changes, the numerical value changes. So N1 U1 is equal to N2 U2, but the net resultant value is constant. But numerical value is inversely proportional to the unit. Larger the unit, smaller the numerical value. Smaller the unit, larger is the numerical value. This is the inference we are making before getting into the topic called measurement. So I will once again repeat. Physics is really interested in studying about the properties of matter. In order to study the properties of matter, I need a scale. In order to construct a scale, I need a unit. A physical quantity Q can be expressed as magnitude into unit, N into U. When the unit changes, magnitude changes, Q is equal to N into U. That can also be expressed as N1 U1 is equal to N2 U2, but Q remains constant. So the numerical value is inversely proportional to the unit. When unit increases, numerical value decreases. When unit decreases, numerical value increases. So unit and numerical values are inversely proportional to each other. Inversely proportional to each other. So magnitude of a physical quantity is expressed by the equation N into U, where N is a real number and U is called the unit of measurement. For some quantity, there may be only a number and no unit. For example, there are some quantities which are having no unit. For example, refractive index, specific gravities. These are all the quantities which are having no unit because it is expressed in the form of a ratio. These physical quantities are mere number, pure number. So we should remember quantity is expressed in the form of N into U. When U becomes 1, N will be the value of the physical quantity. Example, refractive index, specific gravity. So N1 U1 is equal to N2 UT, but the net resultant quantitative value is constant. N is inversely proportional to U is the basic formula we have first derived. So let us learn the properties continuum. Physics is interested in studying the properties of matter. Physics is really interested in studying the properties which are quantifiable in matter. Quantifiable physical properties of matter requires a scale. In order to construct a scale, I need the basic unit, which is universally acceptable. But there are three important properties for the unit: easily constructible, very accurate, and universally acceptable are the three important parameters for the unit. Next, for the measurement, I need a scale. Scale needs a unit. Units combination can be called a system. So, gradually we are moving on to property of matter is if it is quantifiable, we can be able to measure the properties of matter. The measurement of the property is possible by means of a suitable scale. A suitable scale may be constructed by means of a unit which is universally acceptable. The combination of unit can form a system. Next, system is nothing but a combination of units. For example, in mechanics, we are going to define 4 important systems. FPS, foot-pound second. Mass, length, and time are represented by foot-pound and second, which is used in the ancient times, which is the unit are easily constructible but not accurate. The next comes the CGS. Length is measured in centimeter. Mass is measured in gram. Time is measured in second, which is very accurate, but it is not easily replicable. Third one is MKS, large, but not universally followed. So we are having an international unit called SI, where the units are easily constructible, the units are more accurate, more reliable, more universally acceptable because it was defined by universal facts. So, scale, unit, system, and different types of system. Among the system, which is best also we have seen. Now, we are really going into the different types of units. Fundamental unit, derived unit, practical unit. So, physics can be broadly classified as classical physics and modern physics. Classical physics and modern physics spread in 3 domains: macro, meso, micro. In all the 3 domains, physics range is very different. In order to measure the properties of physics, we need some fundamental unit. So physics really defines 7 fundamental units. The other unit is called derived unit, which were derived from the fundamental unit, Length is the fundamental unit. Area is the derived unit. Length is the fundamental unit. Volume is the derived unit. From the fundamental unit, by multiple, we can able to derive the next unit called derived unit. But generally, in practical life, we may be using a unit which is called conventional unit, practiced in daily life. So, for measurement, we need a scale. To construct a scale, we need a unit. The unit may be classified as fundamental unit, derived unit, practical unit. The combination of units is called system. So, now we are passing on to the next. Types of physical quantities, ratio. We already told you, physical quantity Q may be expressed in the form of N into U. If U becomes 1, Q is equal to straight away N. When a physical quantity is a ratio of 2 similar quantity, it has got no unit. For example, relative density. Density of the object to the density of water. Refractive index. Velocity of light in air to the velocity of light in medium. Strain. Change in dimension to the original dimension. All the 3 things are nothing but the ratio. The ratio is the mere numerical value. Angle is an exceptional physical quantity, which though is a ratio of 2 similar physical quantity, arc by radius, but still requires a unit called degrees or radians to specify it along with its numerical value. Ratio is nothing but two similar quantities ratio is going to give a value which has got no unit. Relative density, refractive index, strain are some examples for it. Angle is also defined as arc by radius, but it has got a unit called degree or radian, which is entirely different. Now we are going on to the scalar. The quantity which is do not have any directions, length, time, work, energy, distance. These are all the things which are having no directions. Magnitude of the physical quantity can also be negative. In that case, negative sign indicates that the numerical value of the quantity under consideration is negative. It does not specify the direction. For example, length is negative means actually the length is measured in the left-hand side. So, the quantity which has got no direction may suppose to have a negative value based upon the quantitative numerical value. Scalar quantities can be added, subtracted by using ordinary mathematical rules and regulation. Next quantity, a quantity which has got magnitude and direction, displacement, velocity, acceleration. Further example, vector physical quantities can be added and subtracted by means of separate vector laws. There are certain physical quantities which behave neither as scalar nor as vector. For example, moment of inertia I is equal to mr square is not a vector. By changing the sense of rotation, I is equal to mr square, where m is called mass, r is the distance of the object from the axis of rotation. By changing the sense of rotations, its value is not changed. It is also not a scalar, and it has got different value in different direction. Such physical quantities are called tensors. Ratio, scalar, vector, tensor, angle. These are all 5 types of physical quantities. Now let us recollect what we have learned so far. In order to measure the properties of matter, I need a scale. In order to construct a scale, I need a basic thing called unit. The arbitrarily, universally acceptable thing is called unit. Unit can be classified into 3 types: fundamental unit, derived unit, and practical unit. In physics, there are so many branches spread in 3 important domains called macro, meso, micro. In all the 3 domains, the properties of physics can be measured by means of 7 fundamental quantities and 2 supplementary quantities. The 7 fundamental quantities are called fundamental quantities. Anything that is derived from the fundamental quantity is called derived quantity. In practical, we are using some special units for mentioning the physical property. Next, types of physical quantities: ratio, scalar, vector, tensor, and angle. Ratio, 2 similar quantities, ratio is going to give only the numerical value. Scalar, only directional value, only numerical value, no directional value. Vector, numerical plus directional value. Tensor is neither a scalar nor is a vector. Example is moment of inertia. Angle, though it is a ratio, it has got a definite unit called degree or radian. So, fundamental quantity. Out of the large number of physical quantity exist in nature, there are only few quantities which are independent of all other quantities and do not require the help of any other physical quantity for their definition. Therefore, these are all called absolute quantities. The quantities are also called fundamental or base quantities. Macro, meso, micro are the 3 domains. In order to measure the properties in all the 3 domains, we need 7 independent quantities. These quantities are called fundamental quantities. All other physical quantities can be derived by suitable multiplication or division of different powers of the fundamental quantity. They are called derived quantity. If length is a fundamental quantity, area and volume can be derived by expressing L square as the area, L cube as a volume. So, mechanics uses only three fundamental quantity: mass, length, and time. With the use of the three fundamental quantity, we can derive so many physical quantities. We are going to see the same thing in dimensional formula calculations. Mass, length, time are the three absolute base unit in mechanics. We are using the base unit for defining all the mechanics properties of the matter. So, system of unit. Combination or a set of unit is called system of unit. It contains both fundamental and derived. Then we already know FPS, CGS, MKS, SI are four fundamental systems. FPS is old one, CGS and MK is new one, SI is the standard international. Now we are really following. So we have already defined the system of unit is one which is easily constructible, accurate, universally acceptable. So based upon that, we are really segregating the things. Now we are passing on to the practical unit. Length has got so many practical units because we already told you macro, meso, micro. So length spread in a big range. 10 power minus 15 to 10 power 26. So 10 power minus 14 to 10 power 26. The range is 10 power 40 times. So there are so many practical units that are really being used for length. Likewise, there are so many practical units are really used for mass. Likewise, there are some specific method by which these large and small units can be expressed, because SI unit follows very, very important decimal system. So we can use 10 power. So in order to deal the micro, very small, in order to deal macro, which is very large, we are using the 10 powers. 10 powers can able to define the matter more precisely. So in SI unit, standards of length are expressed by universal truth. Here it was really represented by the wavelength of a particular spectrum. Measurement of length, small, large, medium, can be really based upon the measurement least count. We can able to measure the lengths. For example, meter scale, vernier calipers, screw gauge, spirometer measures the mesosphere measurements. So least count of a meter scale is 1 millimeter. 0.1 millimeter is the least count of a vernier calipers. 0.01 millimeter is the least count of a vernier screw gauge, also for spirometer. For example, meter scale 1 millimeter is divided into 10 parts in vernier, 100 parts in screw gauge. So we got the least count. Another things, in order to measure the large distance, interplanar distance, distance of the planet from the Earth, we are using a method called parallax method. We can go in detail about all these things in a different part. Now we have learned about 6 important learning outcomes. Physics deals with the matter. In order to study the properties of matter, we need a scale. In order to construct a scale, we need a unit. Unit is the fundamental base by which a scale is really being constructed. Unit can be classified into 3 types: fundamental unit, derived unit, practical unit. Fundamental unit. Physics falls under 3 domains: macro, meso, micro. In order to measure all the three properties in the domains, we need 7 fundamental quantities which are all independent of each other. Anything that is derived from the fundamental quantity is called derived unit, which is called derived unit. So system is nothing but a combination of unit. We got FPS, CGS, MKS, SI. These are all the system. System is nothing but a combination of unit. Mechanics has got the combination of mass, length, and time units. So with the 3 unit, the whole mechanics branch can be explained. Likewise, system can be classified as FPS, CGS, MKS, SI. System has got 3 important properties. Number 1, it should be easily constructible, accurate, universally acceptable. SI unit is universally acceptable now because it has defined the unit by the universal fact. We can see this next part in the coming classes. Thank you.